Before I show how to do this absolute value problem, I just want to talk about absolute value in general. Basically, if you're talking about 2 points, say the point 7 and the point 12 on the number line, I asked you to plot those, no problem. You could do that. If I asked you what the distance was between those 2 points, or how many units between those 2 points, you could get that answer by going 7 take away 12. And what do you get? You get -5. But the number of units between those 2 points isn't -5, it's 5 units. So when we're talking distance between points on the number line, and how many spaces are between those points, we really always want to talk just the absolute value. And because you're using absolute value, you can do the problem 2 ways. You can go 7 take away 12, or you can go 12 take away 7 and get absolute value of 5, which is indeed 5. So the order in which you do the subtraction to find the number of units between each point doesn't matter, because we're using absolute value so that we always get a positive, because distance has to be positive. So there's one example. Let me do another one. You can also do this problem by plotting the 2 points on the number line and counting between the 2 points. For example, if this was 7, 8, 9, 10, 11, 12, and this was 12 on the number line, how many spaces between? 1, 2, 3, 4, 5. So you could always plot points and count the number of units between them. That's kind of a slower method to do this problem, and I really want to see the algebra involved, so it's not necessary to do the counting using the number line. All right, let's do another example. Suppose I had the point -3 and -15, and I want you to find the distance between those 2 points. Again, just like in the first one, subtract the 2 points. So -3 minus -15. That becomes -3 plus 15, right? Which becomes 12. What if you had done it the other way, though? -15 take away -3. You would get -15 plus 3. You would get -12. But again, if you always use absolute value when you do these, then you come up with the positive no matter which way you subtract the numbers. And basically, that's why we use the absolute value, is to make sure when we're doing distance, we always come up with a positive answer. So it doesn't really matter which way you subtract the 2 numbers, just plain old subtract them. All right, let's take 2 more. Suppose I did -8 and 11, and I want to know what's the distance between those. So what do? You subtract them. Does it matter which one you put first? Not at all. Put them in absolute value and do -8 take away 11. Do the arithmetic. What do you get? -19. So absolute value of -19 is 19. And again, I could also do that one the other way. Oops, I'm running out of space here. Right? I could do 11 take absolute value, 11 take away -8, and I get absolute value of 19, which is 19. So absolute value is a way of finding distance. Now, let's go to number 6 here, or an example like number 6. Okay, so solving absolute value problems. There's 2 different ways to solve them. One way, using the number line. And basically what this is saying is that the distance between 5 and some number x, the absolute value of that distance is 2. In other words, if I knew where x was and went 2 units on both sides of where x is, I'd have the answer. So how do you find that? Well, in terms of the number line, to find that, first of all, you have to find the start. So to find the start, basically, you just take what's inside the absolute value and set it equal to 0. And then solve it. So in this case, I get 5 equals x, add x to both sides. I prefer to write this x equals 5. That's our start point. So now if you think on the number line, if x is 5, the absolute value is 2 units on both sides of 5. So that means the answer would be 7 And then what's 2 units this way? 5, 4, 3, 7, and 3. So the answers to this are x could equal 3 and 7. That's one way to solve the problem using the number line. Now, there's another way to solve the problem using algebra. Basically, you take what's inside the absolute value and you do two separate equations. You set, and you do that because whatever's in here has to equal 2. Well, if you think of inside the absolute value, what things could be in there that would be equal to 2? I can think of 2 different answers that could be in there and equal to 2. Absolute value of 2 equals 2. Absolute value of negative 2 equals 2. And because there could be 2 different answers, to solve this problem algebraically, you take what's inside the absolute value, 5 minus x, and you set it equal to 2. And you take 5 minus x and you set it equal to negative 2. If you solve both of those, you should get these 2 answers. So let's do that. Subtract 5 from both sides. So I get minus x equals minus 3. Multiply both sides by negative 1. X equals 3. There's one answer. All right, let's do the second part. 5 minus x equals negative 2. Subtract 5. Negative x equals negative 7. Multiply by negative 1. X equals 7. So there's the algebra way to solve absolute value problems. It's nice to be able to look at them on the number line. Here we found the start point, right? And then we counted 2 units on both sides of the start point. I prefer that you use the algebra method and you solve both ways, solve both methods for getting the answer. So let me do another example that has greater than and less than for you. Okay, I've got 2 variations of this problem. All right, one is a less than and one is greater than or equal to. I have an easy way to remember. I think of less than as having less work and greater than as having more work. When you do a less than problem, you can set it up by going 5 minus x is less than 2 or greater than minus 2. And then the problem is like a triple inequality here, and you just go about solving it by working with the middle first. Subtract 5 from both sides. And what do you get? Let's see, I get negative 7 less than negative x less than negative 3. Oh boy, that's a negative x. I want to solve for positive x. So how about if I multiply or divide by negative 1? I'm going to divide by negative 1. That makes that a positive x. Whatever I do in the middle, I have to do on both sides. Divide by negative 1. So this becomes a 7, and this becomes a positive 3. You notice I didn't put the symbol yet? I don't know if you remember this from Algebra 1, but whenever you're solving inequalities, if you divide by a negative, you have to switch the way the symbol goes. So here, what does this mean, and how do I put it on a number line? Well, it means x is between 3 and 7. So, this is 7, 5, 6, 5, 4, 3. So, x is any number between 3 and 7, not including the 3 and 7. Open circle, and everything in between. Now, let's see what type of answer I get when I solve this one that's got a greater than or equal to. The equal bar would just put solid dots. You know that, right? Okay. Well, when you have a greater than, remember I said these are more work? So you do this equation. 5 minus x is greater than or equal to 2, or 5 minus x is less than or equal to negative 2. You account for both the positive and the negative of the absolute value. And when you change the symbol, it's like multiplying by a negative, so you change the direction of the way the symbol is facing. Now, again, you just solve it. So minus 5, so I get minus x greater than or equal to minus 3. Divide by negative 1. X less than or equal to 3. It's one answer. Let's do this one. 5. Let's subtract 5 from both sides. Alright, when I do that, I get minus x less than or equal to minus 7. Divide by a negative, x greater than or equal to 7. Remember, switch the sign. How do I put that on a number line? Alright, so x is greater than or equal to 7. So if this is 7, 6, 5, 4, 3, and this is 3, x greater than or equal to 7. Close circle on 7, and everything in that direction. Less than or equal to 3, close circle on 3, and everything in that direction. So, there you go with a graphic representation of the answer for the two absolute values, again showing the algebra solution. So, less than, you set up as a triple, less work, and the graph is usually between two numbers. Greater than or equal to, the graph is usually to the outside of both of the numbers. So, good luck with the rest of the homework.